So, dear colleagues, just briefly, we are starting the second day of the sixth international conference on European dimensions of sustainable development. We had, I guess, really interesting and successful first day of plenary reports, and I'm sure that today we have not less interesting reports and activities. And the first section will be about environmental sustainability. Our moderator, our colleague Evgeny Shapovalov. So, Zhenya, please. And I cannot hear Zhenya. I guess again he may have some problem with internet connection.
Yes.
Yeah,
I'm here.
Yeah.
Yeah, okay, colleagues, it's a pleasure to be here and to chairing this part of the conference. And now we are going to the first speaker. It's Nina Pavlyuk. You're welcome. We're proud of our cooperation with Bruno and hoping it will be continued. So, Nina, you're welcome.
Thank you very much. Good morning to everyone. Let me share my screen. Do you see my presentation?
Yes, we see.
But I will just.
But not full screen.
Yeah, I'll just try to apply it. But for some reason, I cannot do that. 1 second, please. I'm sorry. Yeah. So yeah, so if you don't mind, I will probably then present like this. 1 second, please. So yeah, first of all, I would like to thank to organizers for inviting me to participate in this conference for the second time already, and I'm really happy to be here again. My name is Nina Pavlyuk. I come from Kiev. Currently, I'm located in Brno and work in Masaryk University as project assistant for the Stockholm Convention Regional Center hosted in Retsitox, Masaryk University. So I would like to start with a brief remark because when I was preparing this presentation, primarily I had in mind young specialists, researchers, and students, the next generation of Ukrainian experts that will be working on achieving sustainable development goals in Ukraine and anywhere across the globe. But at the same time, I hope that our experienced colleagues will also find something useful for them in this presentation. As it was mentioned during the plenary session yesterday, to face the challenges that Ukraine is currently facing, it is important to build new expertise and spread it around Ukraine in young generation. And one of the fields of expertise essential for achieving sustainability is risk assessment and management of chemicals, especially when it comes to achieving such sustainable development goals as good health and well-being, as it gives us understanding of pollution exposures and health effects, clean water and sanitation, sustainable development goal number 6, sustainable development goal number 11, sustainable cities and communities, considering air quality and waste management, and responsible consumption and production, sustainable development goal number 12, I'm sorry. And in this presentation, I put together some tools and opportunities that might be useful for the young specialists and future experts in the field. So on this slide, I would like to briefly describe and introduce the online course on the assessment of chemicals and strategies to reduce risk introduced by Stockholm University. This course was developed by the Department of Environmental Science at Stockholm University. Usually it takes place in spring, in April, so now it's started not that long ago and currently ongoing. It is open to all, but the target audience is environmental scientists, decision makers, policy makers, regulators, and medical professionals from all over the world. The course consists of pre-recorded lectures, 6 lectures, self-assessment exercises, and extremely interesting interviews with experts representing different international organizations, including WHO, FAO, and UNITAR. There are 6 models describing the key elements of risk assessment and management of chemicals: hazard identification, hazard characterization, exposure assessment, risk characterization, and risk reduction. On this slide, you can see the primary literature for the course, the guidance on hazard and risk assessment of chemicals, and the guidance on risk reduction, which are especially of interest to the countries aiming to become a member of European Union. And also, I put on this slide the website of the course and the contacts of course coordinator, Marlene Ogerstrand, in case someone is interested in the contacts and is eager to reply. On this slide, there is some sources of data for hazard identification. For example, database of European Chemicals Agency, ECHA, ECHEM portal, the database of United States Environmental Protection Agency, EPA, and information system of the Federal Environment Agency located in Germany, ETOX. And also I added some scientific platforms which are, of course, well known, but just to make this list more or less complete. So next slide. This slide is devoted to a very interesting partnership called PARC. It is a partnership for the assessment of risk from chemicals. This is the co-funded Horizon Europe partnership for 7 years that started in May 2022. The mission of PARC is to address current and emerging chemical safety challenges and enabling the transition to the next generation risk assessment in line with European Green Deal. The PARC program has 3 main objectives: develop the scientific skills needed to address current and future challenges in chemical safety, provide new data, methods, and innovative tools to those responsible for assessing and managing the risks of chemical exposure, and strengthen the networks between which bring together across actors specialized in the different scientific fields contributing to risk assessment. One interesting project which was developed under the PARC initiative is called Parkopedia. Parkopedia is the online knowledge management and community platform open to the whole community of professionals in chemical risk assessment. And you can also see the website of Parkopedia. So what Parkopedia can offer you? First of all, it's access to articles and content relevant to the topic of chemical risk assessment. Also, it can help you to make your work visible to other researchers and learn faster about work and results of work from other researchers across the globe. Also, it allows you access to open positions. It informs, you can inform others about your event or some events you are hosting offline or online using this network. You can identify potential partners for cooperation. You can gain visibility in the international community as an expert. You can stay in touch with next generation of risk assessment researchers. And what is also important, to participate in discussions and debates or initiate discussions on topics you're interested in. And to join Parkopedia, you just need to register using your academic or working email. And on this slide, I also indicated some other information sources on assessing chemical risks in food that might be of benefit. I hope that some of the information from this presentation will be helpful to some of the participants. And I strongly encourage our new generation of experts, be it risk assessment of chemicals or some other field, to think big, to look wide, and to become really outstanding professionals to contribute to sustainable development in Ukraine and worldwide. Thank you very much for your attention, and I welcome you.
Okay, colleagues, feel free please to ask questions.
May
Yes, sure.
thank you very much for your report and your valuable contribution. My question: you now have Ukrainian background, yeah, and let's say Czech Republic EU background in education, in science. For your opinion, the most valuable contribution, the most valuable part which we may take from European partners to our joint research and maybe to our national system of education and research. Expertise, equipment, validated method, or all of them, what do you think?
Yeah, I would say that all of that you mentioned. I mean, definitely, you know, some like expertise. Of course, I mean, as we are now, you know, aiming to become a part of the European Union at some point, we of course need also to look at regulations and legislation, and to, you know, to make it meet the requirements. So definitely there is a lot of, I mean, there is a lot of information very useful for us now on this particular period of time, both practical, theoretical, everything, especially as we are aiming to go to EU, as for example, Czech Republic already a member, and so they already using, know all the system, all the legislation, all the regulations are in place here. So there is definitely a lot we can take.
Okay, thank you. All of them. Okay, I got it. Yeah, thank you.
Okay, maybe someone also have a question?
Okay, can I ask you, now when the war in Ukraine unfortunately is going on, we forget sometimes about more less important things, like more less war-related things. And for instance, in foreign countries, including Czech Republic, drivers are always worrying about the exhaust of their cars. And in Ukraine, the situation is much more loose. And I don't see here drivers worry too much about they can be stopped and checked, the exhaust of their engines. Okay, so what do you think is the contribution of these looseness in the strict control of the exhaust values in Ukraine and in Czech Republic? Like overall contribution to the pollution or in the environment?
I mean, definitely for me, it's hard to assess. I'm not expert that could, provide you with some like data on that, but just like on my, how to say, subjective opinion, I mean, definitely it also affects, yeah, along with all other negative effects to the environment that we have now. So unfortunately, but I mean, yeah, I think, yeah, once we will, put our legislation in harmony with the legislation of EU, this situation will improve, I guess.
Thank you.
Okay, colleagues, feel free, ask questions. We are here to communicate. Okay, then there are no questions. Thank you so much, Nina, for such interesting, and I'm sure that this is important presentation, especially for opening of the conference. And now we are going to our second presenter, Wolfgang Gabauer. We are also very happy and proud that we have such broad cooperation partners list, and one of them is the University of Baku. It's a pleasure also to say that we met with Wolfgang at National University of Food Technologies. We have photos. And now you're here and you can also be again part of National University of Food Technologies as presenter in this conference. Wolfgang, you're welcome.
Thank you. Thank you for the invitation. My name is Wolfgang Gabauer, Boco University, Vienna, Austria, a biogas research consulting group. And within the next minutes, I will shortly present some results of a EU project, Horizon project we are working on. It's on the topic of biogas production of wastewater from industry, food and beverage industry, more or less, yeah. So the project is called SimSites. In this EU project, we have more than 30 project partners, and we have 4 so-called ecosites throughout Europe. These are pilot plants in different industries and treating different wastewaters. And in our case, in Austria, we are treating the wastewater from a meat processing company to produce biogas and also finally process water. Because the topic is climate change, especially in Greece and Spain, a lot of industries using groundwater, and the groundwater levels are going down, of course, yeah. And so there's a big need to produce processed water and also energy, renewable energies, yeah. And we started with a lab reactor, pilot plant in lab scale. And the technology we are concentrating in this case is anaerobic membrane bioreactor. So that's a technology, maybe some of you know. It's you can treat big amounts of wastewater and hold back the biomass in the digester. So we had here a pump, a feeding pump with the wastewater going into the digester, and also with here a membrane, and with a recirculation pump, the digester content goes through the membrane. In this case, it's a microfiltration membrane, and we are producing permeate. And we are further treating this permeate, yeah, and also biogas. And the volume of this lab digester is about 18.5 liters, temperature 37 degrees. Gross low velocity over the membrane is 2.5 meters per second. And ceramic ultrafiltration, we have 0.2 mercury. And this is, yeah, the system in the lab, the digester, picture of the digester, the barrels with the substrate, with the wastewater, and also a barrel for collecting the permeate. And we have a system The biogas goes through gas volume counters, and finally we also measuring the gas quality with a gas measurement system. Yeah, these are the very first results. We reach a COD reduction from the wastewater of 82 to 98%, depends on the organic loading rate in the reactor. We have up to now reached 3 grams of organic dry matter per kilo and day. And yeah, up to now we have treated more than 800 liters of wastewater in this lab reactor and have a quite good CO2 reduction, yeah. And then the next step was also in combination with this lab reactor, a desulfurization column, a microbiological biogas desulfurization. The biogas from this lab reactor goes through this desulfurization column, and with desulfurization bacteria, we are producing sulfuric acid. And yeah, it's a standard technology which is already used at biogas plants, which have sometimes very high protein content in the substrate, and therefore also very high H2S concentrations in the gas. And yeah, we are changing the media when the pH is reached, going down to 1.5%. And it's working very fine. And we are collecting the sulfuric acid to further use the sulfuric acid in a hollow fiber membrane to treat the permeate, to absorb the ammonium or the ammonia from the permeate with the sulfuric acid. So these were the very first tests. It's a self-made module, hollow fiber module, and we are now testing also from the company 3M modules which are used. And here in the lumen of the membrane, we are pumping through the sulfuric acid. And here, this is not the permeate, but this is a standard solution. We have here ammonium bicarbonate solution, and we are extracting the ammonia with the sulfuric acid. So the ammonia is gaseous phase, yeah, goes through the membrane and is absorbed in the sulfuric acid, and we are producing ammonium sulfate, so a fertilizer. So we are reducing in the permeate the nitrogen concentration and also reducing the H2S in the biogas to produce ammonium sulfate, high valuable fertilizer. And it's yeah, up to now working very good, but yeah, the membranes are sometimes breaking, and yeah, we have some troubles to produce these modules, but now we are moving to this available membranes on the market. But the lumen in this case is very, very small of these membranes, and yeah, it has to be particle free. That's the challenge. The sulfuric acid. This is the location of the so-called ecosite in the region of Tulderfeld, where we placed our pilot plant. This was the next step then, from the lab scale to the pilot scale. And this is Bergerschinken, the company which produces the wastewater. And we have, this is the company Bergerschinken. Yeah, they have about 750 employees, and they produce up to 650 cubic meters wastewater per day. And they are producing 28,000 tons of sausages and ham per year. So they are, for Austrian dimensions, a very big meat processing company. And we have placed here on this location the pilot plant. And you can see here the scheme of the pilot plant. We have a flotation unit in 2 containers, and the sludge goes to a substrate tank, and the flotation sludge, together with blood from the slaughterhouse, is pumped into the digester. This is a 3 cubic meter digester, hydraulic mixed without the steering unit. And the water after the flotation, we are cleaning with ultrafiltration and nanofiltration unit. Yeah, there are some pictures of the containers. The blue containers here is the flotation unit. This is the biogas container. The container with the biogas plant, substrate tank, small office. And here we are planning another pilot plant for cleaning at the local wastewater treatment plant, the wastewater after the wastewater treatment plant to get rid of hormones and other stuff. Yeah, so that's then the third cleaning step. This we will realize within the next year, hopefully. And we are treating with this pilot plant up to 4 cubic meters of wastewater per day, yeah. Together with blood. Here are some pictures, additional pictures. Flotation unit. Here we are feeding blood from the slaughterhouse. We have to take care, of course, on the nitrogen ammonia concentration in the digester to avoid nitrogen inhibition. Yeah, this is the gas storage. And here we are collecting the wastewater from the company. And here is the membrane container with, in this case, nanofiltration, yeah. But we are now starting up the flotation unit. We have some problems to get the correct amount of flocculants and so on. And then we are starting within the next weeks the membrane units. The digester is working very well at the moment. Yeah, there are also some pictures of the biogas plant digester. And this is a Vita for gas quality measurements, and we are monitoring the digester. But it's a challenge because we have used inoculum from a wastewater treatment plant, and we increase the nitrogen concentration very fast. So we, increased the ammonia concentration too fast. So we had some troubles, but we are monitoring, and now we are going down with the nitrogen concentration. And maybe I will go down. We also have the possibility, of course, to use this digester as anaerobic membrane bioreactor. We can also recirculate digester content directly to the membrane, yeah. Or the conventional system, only the flotation, the sludge from the flotation unit uses substrate. But the challenge is an anaerobic membrane bioreactor, it's a good technology, but the energy consumption is very high because you are pumping the digester content all day throughout the membrane. So the energy consumption is very high, and we have to clean up the permeate then finally and to reach a very good quality of this water that can be used as process water in the company. That's the challenge. And we are comparing the membranes, this ultrafiltration and nanofiltration technology with this hollow fiber membrane. There are two technologies, and we are comparing then finally the efficiency of these two technologies. Yeah. Yeah, that's all. If there are questions, I'm happy to answer.
Okay, you're welcome to ask questions. Does someone have a question?
Maybe I can ask. Thank you for the nice presentation. What is the average rate of recovery of nitrogen and sulfur in your system?
Yeah,
you.
that's a good question. I can show you. In this case, the H2S removal rate is very good because we are going into the column with a H2S concentration of about 2,500 ppm up to 3,500 ppm. It's that high because we are feeding blood additionally into the digester, yeah. And the offlet gas has a concentration of 50 ppm, maximum 100 ppm. So the efficiency is very good. and the difference goes to the sulfuric acid here. So the pH goes down very fast, and we are also measuring the sulfate production with the IC. So up to now, it's working very good. But this is a lab scale desulfurization column. But a lot of biogas plant operators, big scale ones, have problems with this external desulfurization column because it's not everything is going into sulfuric acid. A part only goes to elemental sulfur, and sometimes it's blocking this column. That's the problem with this filling material, yeah. And then finally, the challenge with this membrane, we extract the ammonia through these membrane conductors. It's also a challenge, yeah. In this case, it's batch-wise, and it's effect of pH. So maybe you know the higher the pH, the higher the temperature, the more ammonia you have, yeah. And so you have a good efficiency to remove then with the sulfuric acid, the ammonia. But finally, the transfer coefficient goes down with decreasing ammonia concentrations finally, and also decreasing pH in this permeate. But the efficiency is good, but it takes some time, and it depends on time and membrane surface.
Thank you.
But from this permeate, the COD reduction with the nanofiltration, ultrafiltration, nanofiltration, and finally reverse osmosis will be interesting, but it's a challenge to reach really high quality process water. We will see within the next year.
So I see no question, but Volkan, I have the small one. As generally considered, sulfur is more toxic for anaerobic digestion. You focused on both ammonia and sulfur, right?
Yeah.
Can you say about your practice? In your case, which was more toxic for anaerobic treatment, bacteria?
Normally, the ammonia, the nitrogen, is more toxic. So in my experience, if you have a lot of chicken manure, for example, in your substrate, then you have the problem firstly with the nitrogen, and then because you can normally efficiently remove the H2S, the sulfur, with desulfurization column or conventional blowing air into the headspace or putting iron into the digester. But it's a challenge to get rid of the ammonia. You cannot get rid of the ammonia, but of the H2S, yeah.
Yeah, it was pretty challenging to discuss and to argue for people who work traditionally with non-highly ammonia substrates that ammonia is also very, very important, and for this case, even more important than sulfur. That's why I asked. Okay, so I see no question in the section, and then thank you, Volkan.
Welcome. Thank you for the invitation.
Yeah, thank you so much. Okay, Mikhailo Burak and Oksana Markovos, sorry. You're welcome.
Zhenya, the next is Peter.
Okay. Sorry, then Peter, you're welcome.
Hello.
Introduce, please, Zhenya.
So can you see my screen already, or?
Yeah, we can see.
And it's a presentation.
So the Peter is a chair of bioprocess engineering at Technical University in Berlin. So we are happy to hear your presentation.
And do you see also the presentation mode?
Yeah.
Okay, perfect. Okay. So thank you very much for inviting me. So thank you to Igor and Sergey who have contacted me, and I know already Sergey for many, many years, and we are even privately connected through our children. And yeah, 1 year they have even presented in this conference, so I know also the conference since longer time. So I'm welcome here, and it's very unfortunate that the conference is in such situation. So it would have been very nice to meet in Ukraine altogether. Yeah. I myself, I'm a microbiologist, working very much with, or have worked with many difficult to express proteins. A challenging protein which we currently do, which has to do a little bit also with the energy sector, but also with biocatalysis, is hydrogenases. Yeah, very complex enzymes with metal centers, different subunits, partially also oxygen intolerant. Yeah, so and proteins like these have been produced normally in microgram per liter levels. And our aim always has been for many of such proteins, technical enzymes, but also for medical proteins, to bring them to a gram per liter level so that they can be really produced. Yeah, and it's now about nearly 30 years ago that I said, okay, how are we working as biologists? It takes everything so long. As you know, pharmaceutical today takes about or costs about development costs about 2.6 billion euros. Yeah, so it has increased even during the 30 years, even through phase 2 of the clinical trials. Less than 30% of the compounds pass this, yeah, which of course contributes very much to the costs. We have development times of more than 10 years for bioproduct, which of course limits in principle all the direction. And that has brought me already in the 2005, 2006 to the vision that we said, okay, it would be very nice, tell me a molecule, I give this on the computer makes some bioinformatic analysis, then in principle makes automatic ordering, and then it goes to the lab, and also in the lab you are not standing there with pipettes, but robots will do all the work. We will bring intelligence here, and what you finally get is the final process which will work out. Yeah, so that's a Jules Verne vision. Yeah, and but we have started then already during my time in Finland to set up to follow this vision and to start with this. And in the last years, we have, of course, there's big developments. Yeah, as you know, all in connection to data, in connection to artificial intelligence, machine learning, computational strength. Yeah, and also the development of robotics and automation. They have really got all very high levels, so that we have today, let's say 20 years later, we have totally different possibilities to in principle setting up such labs. Yeah, and there are some examples worldwide that people have tried to build these automatic laboratories. Some are shown here. Yeah, like for instance, the Materials Innovation Factory in the Liverpool from Andy Cooper. I only want to mention, but also Emeric Cloud Lab and so on and so on. But if you see all these are normally covering only parts of a screening or development process. And what currently still is missing is really bringing intelligence into these facilities and really having a fully automated self-driving lab which combines all elements of bioprocess development. Yeah, so that is our aim. And so we have during the last years built an experimental platform, connected it special with robots and lab automation. And that means that you have to connect growth of cells, cultivation tools with analytical tools. Otherwise, you cannot have bring not intelligent. Yeah, and we have our problems is that analytics normally take time. They normally are very expensive. Yeah, so if you think, for instance, to MS, Quadratov MS, liquid chromatography, and so on, they take and in connection to the time, they limit in principle experimental our experiments control, because in the best way, and if you are an experienced scientist and you run an experiment in the shake flask or in the bioreactor, you follow the values, and by your experience, you maybe will make some changes in the process to bring the experiment to success. Yeah, and integrating everything of this in our facility, doing it fully automatic, is a big challenge. Okay, so we have set up these laboratories with a number of robots which are connected with each other. We have connected to mini fermentations, but also to larger fermentations. We have integrated the full analysis for our cultivations, which is done at line in principle with samples which are automatically taking. Everything is running in the database. And then in principle, the important thing is that the data from the database which are got during the experiment are automatically evaluated by mathematical programs. So we are running mathematical programs like mathematical models doing the process. And finally, we have then feedback control to the reactions so that we can control our fermenters even with, for instance, moving horizon applications, and so that we can see in the future how our process will develop and control this for each of the reactors. Yeah, here's a small look to the laboratory, all of you who are more practical, so that you see. So we have different robots. We have mini bioreactors, which is a 48 bioreactor system where each of the 48 bioreactors can be separately controlled. Then here is a bigger reactor. This is 10 milliliter bioreactors, but this is 100 milliliter bioreactors, 800 milliliter bioreactors. And here we have the advantage, of course, being a little bit bigger, that also we have connected an outgas analyzer so that we can really make the material balance here. And connected to this is extensive analytics. So the very much key element is the Roche ZX HT analyzers for a full medium analysis in very short time. It's itself a robot. We have connected a flow cytometer. Of course, different fluorescence readers, absorption measurement, OD measurement. We can all do also luminescence. We have semi-automized, we have a lab chip tool for gel analysis in also 96 wells. We have now integrated a Raman spectrophotometer so that we can really online follow the reactions. And very, very new through a big prize, which I won last year from Agilent, the 4-liter award. We have connected now a 2D liquid chromatography system with a Quadrotop MS. So we are going now to make full nucleotide analysis from all the fermentations. And also in the future, we want really to go to proteomics here. Yeah, because especially such instruments, it's very difficult to connect also in a laboratory. So we have already 3-4 years ago started to have a mobile robot in the laboratory, which is really driving through the laboratory and bringing, for instance, 96 well plates from the fermentation systems to the analyzer. And this is done fully automatic. Of course, there's a lot of challenges connected to this because I think I have shown this here. This shows a little bit only and should only give you a glimpse on the software, on the packages which we had to program. And so we have different user layers, different things which are automatically done in principle. And then, of course, here the device layer has to be connected with all of these so that everything can start fully automatically in principle if this is needed. And we have a kind of lot of something like modules, which then depends on the specific project can be connected. Yeah, we currently connect also our biopilot plant. Yeah, here this is a 1 liter 6-fold six reactors, which we have now connected to automatic sampling system, where we even can take all the samples, freeze them, and then we can come. And this is now we are going to install this with this mobile robot, so that then this is also taken to the analytical parts. Okay, the basis, and as a biologist, always you think the basis is experiments, but experiments are only necessary to get more information. So really to make process development in the future faster, we need mathematical models. We need digital twins of our process or digital models of our cells to connect this. And this is one of the kind of gray box models which we are using. So we have substrates, we have respiration, oxygen, we have site metabolic production. We also can in these, we have maintenance reactions, but we can also, of course, connect, for instance, product formation. This is now the formation of antibody fragments here in Escherichia coli, which are produced inside the cell, the heavy and the light chains secreted to the periplasm, and then eventually even released to the medium. And we are building such models. And the big challenge always in bio is to build models, and this is big difference from chemistry, is that we have in principle living systems, we have evolution, we have an adaptation of the cells to the exact environmental conditions. So in principle, we have no parameters which are constant over all the time, because the cells is adapting even in the maximum rates. That means we must, the important thing is that depending on what we are doing, if we change the strain, if we change the product, if we change the small things in the medium, we always need experiments to parameterize in principle our cellular model. And we have to do this under different conditions to take into account all conditions which could eventually appear in the final process. Yeah, this is totally different from chemistry. If you think about distillation, you have models since 100 years now. And if you want to build today a distillation plant, or so you simply go to the computer, make the simulations, and then you can build your plant and it will fully work. In bio, we always will need experiments, interesting experiments in this way. Yeah, and this is now, this shows now a little bit the computation layer. So how we do, we have the experiments, we have the analysis, everything is written in a database. And then as fast as the data are in the database, different computational analyses start with this. This is first the data fitting of a glucose pulses, which is the feeding here in the fermentation. The black lines show in principle the fitting, how well the fitting is. All parameterization is connected to a kind of sensitivity analysis. And the big problem is, as we are doing this during the experiments, the simulation has to be extremely fast, and we have to find a compromise between how good we fit the data, how good we parameterize these things on the one side, and the other side, how much computational efforts we take. So the CPU time plays a big role here. Okay, and if we have this set up, what can we do? We can really preset feedings. We can take in our facility strains, for instance, which we never have taken before. We start with no knowledge about our strains. And because we get from the first data, hours of the fermentation, we get already online data. We can in principle adapt our models, parameterize, and look then more and more better to the future, how the process will develop. And of course, we can then also have this control in connection to the future to guarantee, for instance, certain things which we want to avoid, for instance, oxygen limitation or others. Okay, and this shows now the example of such a design of strains. And you see here really the reproducibility of the strains, the fitting, and so that we have in the end of the fermentation, we have all information in principle which we need for the strain to go then to the computer and develop further the processes. For what can you do this? This is an example, an early example from our work published last year, where we worked with Guillermo Gosel and Alvalara, at this time in Mexico. They have created a big library of Escherichia coli glucose consumption mutants, so that means in the glucose uptake systems. And we have analyzed these strains in our system. And by parameterizing this, we have now really the mathematical models in principle for these strains. So if we now introduce, for instance, or want to use them for recombinant protein production or in the process, we can really, in principle, after in principle one single experiment, we have now in principle all these computational information for these strains. Another thing is antibody production here, where we compared large-scale ferment or pilot-scale fermentations with our robot systems, and where we characterized in connection to the different cellular parameters, the different strains, and we can really see, okay, how reproducible are then fermentations, for instance, in our small unit, which is the red bars here, in connection to the others. And we see where are differences, and we can in principle then draw conclusions in connection to the scalability of the process from the laboratory, from the screening experiments to the production scale. Yeah, here's a very nice experiment in connection to a very interesting group of proteins, elastin-like proteins, where we can which are in principle polymers of peptides of 5 amino acids, where you have one flexible position which characterizes the elastic characteristics of these proteins. And so our friend Stefan Schiller in Frankfurt, he has a big library. And we started with the group in Greifswald, north of 200 kilometers north of Berlin. They screened these libraries. They selected finally 2 strains. We got them in our facility, and our aim and challenge was really making only 2 experiments and then having a final process instead of maybe working for half a year or a year to optimize the process. So this went in the 10 milliliter reactors, and you see here by this really online determination and analysis and modeling, we could already run quite well fermentations. So this was 1 fermentation done in 1 single day. Yeah, and you see only, okay, growth is good, glucose, yeah, there's a little bit accumulation in the middle. We could not fully avoid the acetate formation. That means, especially in the end after induction, there's a little bit overflow metabolism. However, the product in principle was quite good. The second step was going then in the 100 milliliter reactor, also fully automatic. Then we had already the information from the very small scale. And here we could then really avoid very good produce, get higher cell densities, and could also totally avoid acetate formation during the longer run of the fermentation. Yeah, so this is an example. And finally, I want to give you one example to tell you in principle what could that make sense for you, because you could ask, okay, now in Germany that they have a lot of money, they build such laboratories, but how can be such a laboratory valuable of you? Yeah, we have opened our laboratory so that you can control our laboratory from the outside. We had, I will show you one example here. This was a competition between 3 modeling groups. Our friend Ernesto Martinez from Argentina. Then there was a group in Hildesheim in Germany. And our group, they had different mathematical models. We were running the 48 bioreactors. Everyone got in principle 16 bioreactors, and they had the chance to in principle evaluate their models. And really, it was a kind of competition. We run this now for the 3rd time already. And they have totally different approaches. They have totally different aims. Or the aim was in principle to get a high cell density, to get a high product. This with different kinds of modeling approaches. Then in principle these fermentations were running, and really interesting that different results were also obtained. But this was fully running at the same time. Different groups in the world were controlling these reactors. And of course, similar like we did for the elastines, things could be in principle, you have the idea for the product. One group is doing screening somewhere in the world. We are getting the experiments here in principle, and data, fair data plays a very big role, using them, optimizing the process, and develop the process very fast. So that is something which we go very much in the future. We currently aim to build blockchains in principle also for really collaboration of different partners with each other, making safe data transfer, really using in principle these possibilities that other labs can control in principle also our facility. And I think that is really kind of vision for the future, which will in principle very much strengthen international collaboration and bioprocess development. Yeah, and by this, I believe that we have today all technologies in principle to make a really change in biotechnology and bioengineering. Yeah, and especially also for such processes with difficult to do molecules. Yeah, however, the big challenge is really all this integration. We have done this trying by learning. We are building now, currently we are planning a big cell culture center with together as an industry private partnership in Berlin here as a test service and training center, and mainly for cell cultures, but we connect this with our microbial unit. And of course, the big challenge is really working interdisciplinary together, using the possibilities which the mathematicians, informatics, control people have in principle done. And currently we are doing this in our laboratory and try this. We learn from this, but I think all the picture should be much bigger, and more people should be involved. And by this, a big challenge is, and I think this is also, I think if you see the Ukraine situation or something like this, the aim of presenting the data in fair data, that means putting them to electronic digital form, bringing them in a machine readable form, I think is very, very important for the future, really making these data usable, bringing them away in principle from notebooks, which in principle make that these data are never visible to anyone. Yeah, and I think this is a big effort which we currently do and try to prove also with our facility how much use is of these kind of fair data systems. And by this, I thank you very much and hope that, yeah, maybe I could give you some visionary ideas also, but maybe this helps also in the future to establish some collaborations. Thank you very much.
Yes, thank you so much, Peter. You're welcome to questions.
Okay, may I start? Thank you, Peter, for the brilliant presentation. And when I look at it, everything is, it sounds like fantastic. It's not any underestimation. And fantastic in all respects, including political dimensions. You are aiming at expressing the difficult to express proteins, and the difficult to express proteins are often multi-units, multi-subunits.
Yep.
So what do you think are the prospects of overexpression of, let's say, fibrinogen? Is this realistic, or it's still like something in still fantastic on this stage?
Yeah, as I think because also, for instance, I do not know exactly. Of course, one has to look to the molecules, but for instance, we have earlier worked with collagens, and I think people are doing today collagens. There are even more companies, one in Germany, but also worldwide. There are more companies. So I think generally there should be possibilities. Yeah, I think the big challenge, whether this is fibrogen or every other molecule, yeah, is today that we very much rely on personal experiences. Yeah, so if you say, okay, you want to make fibrogen, you have to go to databases, and by the ways you are trying you are used to get your information, you are going through and you come to these results or others. But there is, let's say, optimum, which is in principle the knowledge of mankind in principle, which is in the databases, yeah, and which we very often do not exploit fully, yeah. So I think we have to build in bio much more a connection of the different systems, and I think this is something where definitely artificial intelligence can help us very much. Yeah, the problem is currently that all the nearly no data which have been produced in the field of bio are as data available. Yes, you can you can look for structures, you can look for metabolic pathways, you can look for publications. Yeah, but already if you want to go to the data of the publications which people have produced, you have nearly no access. Yeah, because they have disappeared and in normally books, and they are not in the electronically readable form available. Yeah, and I think this is something where we really have to build to use the knowledge of the big amount of money which have been invested in the bio field, I think purely senseless. Yeah, because if the things are not in principle available for mankind, yeah, then we cannot really make a progress in bio. This is our limitation in bio. Think about the Googles, where people every day give them the data in principle free of money in principle. We paying for our experiments, for our instruments, very, very big money, but we don't get the in principle data so that really then artificial intelligence programs can be very efficiently used. We have to find also in our facility new values. We have to create data artificially in principle to get enough of the data, and so. But I think the databases will grow. Hopefully in the future, we need fair data. That is important. Yeah, and I think from this side, then the first thing start if you want to produce fibrogen. Yeah, which is the organism of your choice? What are the costs? What should be the large scale process? At which scale should it be? And then you have to make then in principle on this basis, then rational decisions can be done. Is it E. coli? Is it the Bacillus or yeast, a secretable strain? Is it eventually a plant, which you have, like collagen was very much discussed, okay, that the word collagen, you cannot produce it in the fermentation capacity of the word, so you eventually would have to go to plants and something like this. Yeah, so I think these are all decisions, but as long as you have to do this with your personal experience, yeah, you are always driven by your experience, and you will maybe make wrong decisions, yeah, and cannot in principle use the knowledge which is there.
Thank you.
Yeah, thank you so much, Peter.
May I ask a lot of questions, but better at least one general. I totally agree with Sergey that most of us are really impressed. Yeah, this potential, powerful potential of your facilities. May you open a secret? I guess I mean how does it work in Germany? This financial support of research. I guess it's government and maybe project with industry and grant from research programs. What is proportion? How does it work in your case?
Yeah, as I must say, when I started in 2008, I had nearly nothing. I had 4 co-workers. Now we have over 80. Yeah, and we started very simple with some small industry projects. Yeah, our first robot finally I could buy over the funds which I got as a professor coming to Germany. Yeah, but that was one robot. But we are very fortunate that we are a big city, which has a big amount of laboratories, like in the Charité, like also Bayer as a company. Yeah, and many people are buying robots, but they are standing in the laboratories and no one can use them if the initial people who moved away. Yeah, and we have people were very happy when we came to their labs and said, okay, do you have a robot here which is unused? Can we have this? And we very often they were happy, so that most of our robots today is in principle old instruments, and we had then to find the people who really reprogram them to use the software and so on. Yeah, so that was our start, and it has us taken 10 years also in connection to this two reactor system. We had not the chance to buy the software, so we had to find mathematicians and programmers who programmed everything, and that took, of course, long time. So I said, okay, very much was learning by doing. But then by starting the first projects in principle, of course, we got interest from the industry, also from the pharmaceutical industry. Then we got some funding. We, of course, also worked with joint big projects over state funding, the Ministry of Education and Research. Yeah, yeah, now with this laboratory, we are really more visible, and now it gets also easier. Yeah, it gets also more busy, but we daily get requests from the industry and something like this, and we build now this big academic private partnership network. We hopefully can also build new laboratories. And of course, the big challenge is now we are in the area of microbial cultivations, yeah, but the pharmaceutical industry, of course, mostly is using cell cultures. So the question is always, can the principles which we have, can you do this with cell cultures? And my answer is always, okay, a cell culture is easy because it's growing for, let's say, half a month or 1 month. Our fermentations are over 1 day. So we in connection to analytics and all these getting the data is much more challenging for microbial process. Yeah, but cell culture is much more slower. But we have to prove this, of course, and now hopefully we will go to set up the cell culture center. Okay. Yeah, but it's a steady way, and now, of course, we are looking for bigger amounts. I think in research groups, by having now more people having more visibility, we have now the chance to pay also people who in our group partially, but also connected to our group, which write projects and so on. So you have, by growing, you have to go a more professional way, like in the company, where we have, of course, always restrictions in connection to research institutes that very much we are under control of systems. Yeah, which we very often cannot do, like in a small company by our own. Yeah, but yeah, we have to arrange with these systems, and we have to find solutions. And yeah, this takes time, but I'm very happy how we succeeded by going a solid, steady, stepwise way, in principle, building in principle a solid background for all our work.
Thank you. Thank you.
Okay, yes, and thank you, Peter.
Thank you.
We are going to our next speakers then. So the next speaker is Mikhail Kupik, Institute of Hospital Management and Socioeconomic Geography, University of Szczecin, Poland. This presentation, transformation of energy landscapes, location consideration related to the cumulative environment impact of photocatalytic farm complexes. You're welcome.
Good morning. Do you see my presentation?
Yes, we see
Yes.
you.
Good morning. Thank you very much for invitation. I'm first timer, so please be patient. I would like to share some my thoughts about sustainability of renewable energy sources development from the spatial management point of view. I'm dealing with renewables mostly from this point of view, from point of view of environmental impact assessment and location processes especially. And I will be talking from Polish perspective, which is more or less very similar to other EU countries, with some color connected with really fast development of photovoltaics in last year, according to, of course, mostly changes in local law, local procedure. So this is the Polish color of this process. Around maybe 10 years ago, this fast development in renewable sources occurred in wind turbines, but about maybe 6 years ago, the law changes almost stopped the process. According to a new rule, the so-called 10H rule, means 10 heights of wind turbines. The location of typical farms, the finding area more than 1 kilometer from residential buildings became so difficult that most of the location processes just were blocked. And that was probably the start of better climate for developing of photovoltaics. And we are now in the moment that photovoltaics takes a really important share of our energy mix, and also started to changing our environment, our landscape. Probably it's kind of truism. Energy revolution needs space, but except the advances, there are some constants which are connected with energy revolutions, and especially with development of numerous distributed energy sources like photovoltaics, which are scattered in the landscape. They just need space, and they just need not only space for location, but also for many kinds of additional infrastructure. For example, roads, for example, connected services. We need to change and diversify transmission network, and from spatial management point of view, the most important is conflict between production of food and production of energy, especially connected with production of biogas, but also connected with photovoltaics, which also are located on agriculture areas. This is the chart from yesterday, so quite fresh. We need about 20 gigawatts of energy, and more or less half of that is produced now from the sun, from the photovoltaics. So it is quite significant, quite important energy sources. Of course, we have now ideal conditions for such use because of the sunny weather. From Ukrainian point of view, probably I'm not proper person to ask about it, but probably it is also quite safe kind of production because of difficulties of destroying such network of thousands of small plants producing energy. But it's visible that after about 6 years of development, it starts to be important in Polish energy mix. To be less optimistic, if we look at CO2 production connected with energy, the color is less optimistic according to Poland, and it will be very hard and long time process to change it. So why photovoltaics became so popular and so important for Polish energy production? Most important thing is really easy location procedure. Procedure for location of wind farms lasts several years, mostly because of need of environmental impact assessment, especially bird monitoring, which should last minimum 1 or 2 years. The only obligation, only restriction for photovoltaics now are restriction connected with soil quality. So they are forbidden on the first 4 classes of best soils. We are now in the process of changing spatial management law. So from 2026, there will be obligatorily local master plan on location selected for photovoltaics. There is very simplified assessment of environmental impact. Photovoltaic farms have no emissions, no serious earthwork, no changes in soil permeability, and are easily reversible. So after some years of working, producing the electricity, they can be easily removed and don't change properties of the site. They have also very limited noise and electromagnetic emissions. They doesn't cross the norms. They produce almost no waste and have quite limited impact on habitats. Even if they can create barriers for movement of animals, for example, if we can arrange with owners that they, for example, don't use fences, and the impact is lesser. They also have, comparing to wind turbines, quite insignificant visual impact because of the soil, of the low profile, and especially with masking by vegetation. I'm from Szczecin, from northwestern part of Poland, where is really abundance of extensively used agricultural land, and comparing to other parts of the Poland, really lower density of population. Which leads us to really abundance of location which can be used as space for photovoltaics. Small 2 examples of such locations. We have a lot of extensive pastures because of economical changes in agriculture. They have no use almost today, and they are, if they are used, they are used really extensively. Also, quite a lot low quality arable lands. Part of them are forested, but part of them still last. So there are favorite spots for location of farms. On the right side, there is an example of visual impact modeling, which shows that because of this low 4 meters high profile, farms are completely masked by surrounding vegetation. So they are really easy to hide them in the landscape, especially with that kind of mosaic landscape as we have in Pomerania. I would like to show you two examples, two case studies, which shows quite typical situations connected with maybe we can say disaster of excess, with difficulties connected with popularity of such kind of investment. First example of one of commune located on the lakeland, so quite rich landscape, quite rich mosaic landscape with amount of lakes, river valleys, forests, and scattered plot of arable lands. And on such environmentally rich commune, we have planted almost 1,000 of hectares of photovoltaic panels, which is quite a lot, which is about 5% of arable land. Of course, not evenly distributed, and there are such examples like this village on the map, where because of agreement with local owners, there is danger of quite complete change of land use, of composition of the landscape. Of course, the better part of situation is that there are only plans for this. These 67 plots are in the process of localization, in the process of developing all needed agreements, of developing environmental impact assessment and so on. Only 5 farms are realized, but 36 are in development, so quite a lot. Another example of distribution of farms in this selected commune, it is more than average. It's not typical situation. I show you like extreme, little bit extreme example of such dangers, but just to show that it could be significant change. In present situation, the main problem is not whether and where to locate, but how to connect to networks. So most of the farms probably will have all needed agreements, but will have also problems with connecting to network, which is now in the process of development, in the process of transforming to absorb such change in production of electricity. We are not prepared for this for such situation now, and probably only part of farms really we can observe in the future on the real landscape. Another case study, also quite typical. This is the situation on the outskirts of Szczecin agglomeration. Large plot of lands, 40 hectares on the outskirts of residential area, on the outskirts of area affected by urban sprawl. So still arable land, but in near future, almost sure to be transferred to residential use. interesting thing in this situation is that investors divided the whole investment to 10 separate procedures just to avoid the effect of scale. So just to avoid proceeding with one big farms, let's try with 10 smaller. And it works. In this situation, it works because they can fit to so-called fast localization tract. Commune board assess if such investment has or not have a significant impact on environment. And it means on this fast track, there is a lack of full environmental impact assessment procedure, especially lack of assessment of impact on health of residents, which is important in such situation because it's the vicinity of residential areas. And last but not least, the aspect of spatial house. So we have on the outskirts of residential areas, and we have a really large plot of photovoltaic panels, which stagnate the development of the area for dozens of years probably. And the last interesting thing about this situation is that this investment in reality in the last month was blocked because of the protests of residents. But protests were not connected with environmental issues, but it was typical not in my backyard situation. So they just don't want to have such surrounding land use around their homes. I'm not sure if I would decide for them if I prefer to have 40 hectares of photovoltaic panels or another 500 of residential homes, small one-family homes, and congested traffic around. So, but it helps to resolve this situation. So, some conclusions. We observe a set of very similar pathologies connected with location of photovoltaics in large amount in our region. The first most popular is this one presented in last examples. So splitting investment into parts to avoid full environmental procedures. Also searching for plots in areas without master plans. When about only in Polish situation, only about 30% of land is covered by master plans, local master plans. When you don't have such plans, it's a lot easier to obtain any needed agreements. Also, we observe clustering of investment based on availability of plots and agreements with owners, also willingness or agreements with municipal authorities. So, and that's the reason of such uneven distribution of planned investments. Of course, there's the other side of the process. So, so we develop some preventive measures developed by bodies connected with location procedure, with environmental impact assessment procedures. In areas similar to situation from the last example, they order routine noise and electromagnetic radiation modeling necessity recommendations. It's not because noise is too big or radiation is too big, but because of annoyance to the local residents. So it's only about maybe 30% of the norm but sound connected with inverters and transformers is 24 hours per day. So it's annoying for the resident, and that's the base for altering the project or for blocking the procedure. Other measures assessing the cumulative impact of all investment in the vicinity as a medium for this dividing of larger investment into the parts. So there is obligation to assess, to check cumulative impact, for example, in the radius of 4 or 5 kilometers, just to include the surrounding plots of land connected with the same land use. When we have part of the land of the higher quality or higher environmental quality on the plots planned for investment, the bodies try to exclude from this area this valuable plot of part of habitats. In our condition, there are wetland, ponds, and small patches of trees, patches of forest. Of course, we are hope that situation will improve in next years after changes in the law, especially with this mandatory requirement to have master plan for location planned for photovoltaics development.
Mikhail, I'm sorry to interrupt you, yeah, but is it possible to conclude a little bit, and you will have?
Yes, I'm just concluding. So that's my last word. So thank you for attention.
Oh, sorry. Okay, but this is very interesting presentation, and I'm sure in Q&A section you will be able also to discuss with colleagues more detailedly. But maybe right now there are some questions.
Definitely we have. Yeah, we have. Thank you that you have with us. Maybe just general question. I don't know. Very often we have such information. Just a couple of percentage of Sahara Desert, yeah, will cover all the humanity needs in energy. How realistic it's in terms of transfer of energy? Again, I know, for example, that Ukraine exports energy to Europe. Actually, we may cover some distance. What do you think about it?
It's difficult to answer for me because I'm not a specialist. I'm not an engineer connected with energy. I'm environmentalist. So I have no idea about things connected with energy transfer. I only know that because of disperse of renewable sources, the network should be prepared for such situation. And in Polish reality, there is the main constant for further development. We lack of intelligent power network, and they blocked possibility to access for dozens of new farms.
But sorry, Michał, narrowing my question, yeah? In Polish, for example, typically these solar power plants tried to be located near the consumers, or it's not?
No, it doesn't matter. It doesn't matter. It's not the main issue of localization are availability of the good plots, agreement with owners, with commune, accessibility to power network, the most important, and environmental conditions. So lack of conflicts with protected areas. according to photovoltaics, there are main constants.
Okay.
So there is no need of locating them on in a specific area.
Thank you.
If you don't mind, I also have questions. A question, the short one. So if generalize, one of your important part of presentation is related to environmental impact, right? So can you, in general view, compare is such photovoltaic farm complexes more environmental safely than traditional energy sources like using coal or oils to produce energy?
I think they are more environmentally safe even comparing to other renewable sources. There are just light construction of panels without foundation, easy to remove. They don't change the capabilities of the site, so they don't change soil, they don't produce waste or even gas emissions or something like that. So according to environmental impacts, they are really easier to process, become reality.
Okay, but what about those solar panels? They have like term of use in near to 50 years, right? And they should be changed. And
probably even less, because mostly because of the progress in technology. So I think it will be more 10 or 15 years than 50. And of course, another part of the story is how to reuse them, or how to properly remove them. So according to
during
rules of circular economy.
Yeah, during the term
it's another story.
Yeah, during the term of usage, this is clear that this is greener energy source. But what about utilization of those panels after?
That's another story.
Yeah, okay.
I show you the situation of the direct impact, which is really nice, really easy to predict and to agree with that, but taking into account the whole life of the product, that's another story.
Okay, thank you. So if there are no questions, thank you so much, Mikhail, for such presentation. And we are going to the next presenters. So Mikhailo Buryak and Oksana Markovos from National Technical University Kharkiv Polytechnical Institute and EIHI Zittau Dresden Technical University. This presentation, positive impact of sustainable particles on setting the company's goal for implementation changes. You're welcome.
Yeah, thanks a lot. That will be just me presenting today. Unfortunately, Oksana will not join us. And suddenly, if I drop, probably there is a shutdown of electricity in Kharkiv, but I hope it will not happen. I'll give a quick presentation on our research. I hope you see my screen right. So basically, in our research, we tried to investigate how the integration of sustainability development goals, sustainability KPIs into the core principles of organization can facilitate the organizational scale and agile change management in the companies. When we think about what is a successful organization, probably what we imagine is a company that has a lot of employees working for it. We are thinking about a company that provides a lot of services and products, and also a company with a huge revenue. But again, not unfortunately, but with the popularity and actually an emergent need for the environmental care and sustainability, there has been done a lot of research by other authors from universities and private companies like McKinsey, Accenture, Boston Consulting Group, which concluded that companies which are only thriving for scaling in the traditional understanding within traditional KPIs, only 12% of these companies achieve this result, and that integrating the sustainability practices are also essential for the business operation these days. So what we have in our plate, the UN in 2017 introduced the Sustainability Development Goals, and based on our analysis, particularly goals number 8, 9, and 17 can be used as a pole star or as a compass for the organizational scale. To be more precise, we have goal number 8, which is decent work and economic growth. We have goal number 9, which is industry, innovation, and infrastructure. And we have goal number 17, which is partnerships for the goals. All these goals here and there directly and indirectly relate to the organizational scale in the traditional understanding. So when it comes to the decent work and economic growth, by creating the importance of the employees, providing better work environment, positive one, employees feel more engaged, that results into the more productivity results in the better output, and potentially it results to better and more sales, hence to the increase of revenue, and then to the scale of the organization. Industry, innovation, and infrastructure can be also considered these days as one of the new traditional metrics for the organizational success and organizational scale, because those who can innovate, who can adapt, be agile, be adaptive to the competition in the market, are also doomed to succeed. Because again, the investments in the automation of the processes, new technology can result in the potentially to the cost optimization, and as a result to the increase of revenue. And finally, and quite debative and controversial goal, but it is the partnerships for the goals. I think it contradicts to the only one, the one hence increasing the profitability, environmental. It's also about the environmental impact, to track the environmental footprint. We have a lot of digital solutions in place these days to automate this activity. We have economic growth, which also includes the traditional metrics and responsible sourcing and supply chain sustainability. Employee engagement can be tracked via the level of satisfaction, motivation, and productivity. Again, we have digital tools like surveys to track this over time and also derive the conclusions. And finally, we have the operational efficiency, which is basically the combination of environmental impact and economic growth KPIs. Based on the review of the case studies of Patagonia and Chobani, which fortunately have an extensive public data available around their sustainability activities, we tried to interpolate their managerial decisions into the unified framework that then can be used hopefully by other companies to kind of as the roadmap for scaling and also as the roadmap for implementing changes. Overall, it's based on the Sustainability Development Goals, particularly 8, 9, and 17. And also we defined in kind of the value proposition canvas, what are the pains and benefits, or like pain relievers of implementing the framework. And based on the inspiration of agile methodologies, which is like a popular and extensively used framework in the like in for-profit companies, we defined our own like steps or kind of agile sprint to implement the sustainability practices and changes within the organization. Those are based on the 4 cycles, which are mobilized for change, where the change or the practice is ideated and discussed. Then we try to implement it on the company level, for example, on the department level, and then we do some kind of retrospective and try to scale it and integrate over the company as well. And then we try to sustain it and improve over the top cycle of the within our framework. Also, within each of these cycles, within the retrospective, we suggest to track the KPIs to assess the efficiency of the change implementation. And also, our framework is based on the core principles, which are basically the postulates, and they are described here below. That was our first research, and within like the suggested framework, we will try to extend it and try to bring more Ukrainian companies to extend our case study and prove the efficiency of it. Thanks a lot for your attention, and I'm open to questions. Thank you.
Yeah, is there any questions? Okay, then I have the short one. Do you tested your methodology compared to other, for example, well-known agile or waterfall?
I'm currently having the practice in the IT development company in Ukraine, and I'm trying to cross-check the framework against their actions and bring more statistical data, because the case studies I used in my research, they're for Patagonia and Chobani. These companies are already scaled because they have thousands of employees over the place, and we can traditionally believe that they're successful. But the IT company where I'm having these practice sessions is of 150 employees, and we'll see how the changes and the scale will be facilitated with the implementation of this framework. So that's work in progress for me.
Yeah, cool. Okay, is there any questions? Okay, we have no questions, so thank you, Mikhailo. Then we go to the next presentation. Vera Horkunova, and there is a list of authors from University of Opole, Zabolotny University of Microbiology and Virusology of National Academy of Science of Ukraine, and the Universitat Política de Catalunya Barcelona Tech, Terrassa, Spain. Colleagues, are you here?
Hello.
Yeah. Okay, you're welcome. It's a pleasure that you're here.
1 minute, I will share my screen. Do you see my presentation?
Yes, we are.
Thank you. So, dear colleagues, it is my pleasure to visit your conference and to participate in it. And here we have the team of the representatives of 3 institutions: University of Opole, Poland, Zabolotny Institute of Microbiology and Virology of the National Academy of Sciences of Ukraine, and Universitat Politehnica de Catalunya, Barcelona Tech, Terrassa, Spain. And our pleasure is to share with you our results of the research that deals with microbial metal resistance for the sustainable environment. It is well known that the main problem is the pollution of ecosystems with toxic metals, and this problem is currently very urgent all over the world. So if no action takes place, it will lead to catastrophic consequences for the environment and human health. What are the sources of this pollution? They are both of natural and man-made origin. For example, they are natural outflows of metals from deposits, mining and chemical industry, non-rational farming, and one of the most important problems for environment in Ukraine nowadays, it is the shelling of its territory. So the goal of our work was to study the level of soil contamination in the Kyiv region with toxic metals due to the shelling, as well as to assess the resistance of microorganisms of soil to these toxic metals and the possible pathways of their microbial application for metals detoxification. At the first stage of our research, there was the issue to collect these samples and then to analyze the content of toxic metals in soils affected or non-affected by shelling in Ukraine, and also the number of microorganisms that's still alive in this soil. And here in the picture, you can see the process of collecting of samples. They were collected in Kyiv region near Hostomel, where the entry of Russian troops took place at the beginning of the war in spring of 2022. And here is the results of our research. The measurements took place twice. It was at the end of autumn last year and also in the middle of winter this year. So the time interval was about 3 months between the measurements. And as you can see, the concentration of cobalt, chromium, and lead was almost stable in 3 samples of affected soil by shelling. And also it was similar to the samples where shelling didn't take place. And you can see the amount of toxic metals in the range of 5 to 50 ppm. And only the amount of nickel at the beginning of our research was quite high, up to 400 ppm. But then we also showed that its amount was dropped. Another point is the concentration of iron in soil. So as you know, the amount of iron in soil is quite high, and it is in the range of 1000 ppm. And also our research revealed that after 3 months of our investigation, the amount of iron in some samples was even much higher, up to 3 to 5 times higher. And we could explain that because of the activity of microbial communities that could produce different organic acids, halate some pieces of non-soluble pieces of missiles that are left in soil and mobilize iron into the soil. So this is a great problem, and we suggest that this is one of the main problems for the pollution of soil due to the shelling, because as you know, the big particles of missiles are removed from the places of shelling, but the small pieces like 1 centimeter up to 5 centimeter were not removed, and they are still in soil. And due to the activity of microbial communities, the metals that contain these particles of missiles can be involved in the biological cycles and provoke negative consequences and pollution of the ecosystems in general. In this regard, we also analyzed the response of microorganisms to these situations. And here you can see our study of aerobic chemorganotrophic bacteria in samples that were affected by shelling and not affected. And you can see that the amount of microorganisms is quite high. It is from thousands, hundreds, thousands, up to millions cell-forming units per gram. That is a good result. And also we studied the amount of metal resistance in these samples on the example of aerobic chemorganotrophic microorganisms resistant to chromate. And you can see quite a lot of these microorganisms in all samples. And that means that microorganisms can provide the stability, maintain the stability of their functioning in the presence of toxic metals. Pattern is very interesting and promising to develop biotechnologies based on microbial interaction with metals and to apply microorganisms for metal detoxification in soil. Here we started to study the patterns of microbial resistance to toxic metals and interaction with. These patterns were studied on the example of 4 strains. You can see them. They are Brevonimonas vesicularis, Pseudoatrobacter oxidans, Pseudomonas linea, and Pseudomonas putida. And also you can see the maximum permissible concentrations of different toxic metals. Maximum permissible concentrations, that mean the highest concentration that microorganisms can grow. And you can see these concentrations are quite high. For example, for cobalt, it is up to 200 ppm, for chromate, 250, for nickel, 500, for copper, up to 600 ppm. It is up to 2500 ppm. So you can see that microorganisms can survive at high concentrations of metals. So the next point of our study was to analyze what is the reason of such resistance. For this purpose, we analyzed the genomes of these 4 strains, and here we will show you the results of our study on the example of the first strain. It is Breviodimonas vesicularis USM1. And here you can see the analysis of its genome. It was found that there are 18 genes responsible for metal resistance. Here you can see the list of 6 genes that provide copper resistance of bacteria. You can see their place in the genomic DNA of microorganisms, and also, like an example, here we showed the model of the protein encoded by one of the genes. It is copper-resistant protein B. Most of these genes provide the transportation of copper inside cells or outside cells, but in this case provide metal resistance. The next group is cobalt and nickel resistant genes. You can find here 7 of them, and also here it's their place in the genomic DNA of bacteria. Last group is chromate and iron resistant genes. We have found 3 for chromate resistance, responsible for chromate resistance, and 2 for iron resistance. Also, their place in the genomic DNA, and their function is to reduce metals and transport them. And here you can see the overall summary of our research. Here is the place of all metal-resistant genes that was found in these microorganisms. And to summarize, we can say that these organisms possess high opportunities to be resistant to toxic metals, and it can interact with them in the way of reduction to non-soluble compounds, like example of reduction soluble chromate to insoluble chromium-3 carboxide. And in this case, it can be removed from soil and detoxified, as well as transportation from cell or into cells. And in case of transportation into cell, metal is immobilized. We can say that soil pollution with metals that took place due to the shelling of Ukrainian territories is potentially hazardous for the environment and human health. Soil microbial communities, as well as strains, exhibit high resistance to toxic metals and have a great metabolic potential to detoxify them. The analysis of genomes showed the presence of genes providing resistance to metals, as well as interaction with them via precipitation, reduction, accumulation in cells, and so on. And the prospects of the further research are the development of the approach to regulate the metabolism of microorganisms, to purify the environment, and provide its sustainability. Thank you for attention.
Yes, thank you so much. Is there some question?
May I ask? Thank you very much. I think it's really relevant research for our current situation. Vera, please, how do you think, or maybe you have some information or just your assessment, how effective and how bad will be transfer from contaminated soil into the plants, for example, agricultural plants?
Actually, now we will start developing this approach also. From our previous research, we have found that microorganisms can provide the different kinds of organic acids that are used as chelators and mobilize toxic metals, as I mentioned, from these insoluble particles into soil, and then plants actively transport them inside their organism. So this is quite an urgent problem, and we should pay attention to this, because if we use some agricultural plants on these polluted territories, it can be hazardous. It's from one side, but from the other side, there is the opportunity to develop the biotechnologies that based on some fast-growing plants like usual grass. It can be sown on these polluted territories and contribute to the removal of toxic metals due to its introduction into the body of plants, and then just harvesting them and removing from these territories. So this will be the contribution to removal of metals and to make the soil appropriate for the farming.
So sorry, to clarify, right now, do you have some recommendations, ideas? We should keep these soils some time without operation, I mean agricultural operation, or we may apply effectively, let's say, these particular types of plants, or maybe treat with sorbents or with some microbial communities, or all together.
From our point of view, biotechnologies are the most prospective in this case. So for the beginning, it should be noted that different kinds of biotechs should be applied for the removal of toxic metals from soil, and only then the farming should take place, because if we just use the soil, it can be hazardous for human health. So first of all, biotechnologies, removal, technical, mechanical removal of small pieces of metals from this polluted soil, then biotechnologies for the removal of the residues of toxic metals, and only then farming.
And my very last point, how optimistic are you? I mean, we may totally clean this soil due to this biotechnological approach, or what?
I think you know that all countries have some specific restriction on the amount of toxic metals in soil. So I think there is no need to remove up to zero.
No, I mean back to normal. Yeah, back to normal.
Yes, but it is very to remove the metals to obtain just the concentration that are not restricted in Ukraine to start farming here.
So you are optimistic, yeah. Thank you.
Yes.
Thank you.
Yes.
Thank you.
Yes, that also was my question about dynamic of concentration of these metals, but you covered this by answering on previous question. So maybe also someone have question. Okay then. Thank you, Vera.
Thank you very much.
Thank you for being here. Then our next presentation is by Vladislav Sukshenko. It's method and future prospects of animal fat conversion into biofuel. So Vladislav, we don't hear you. We see your presentation, but we don't hear you.
Now better?
Yeah.
Hello to everyone. I'm glad to present you our presentation, which was made by Vladislav Sukhenkov on Cherkasy State Technological University in Cherkasy, Lesia Avdieva, Institute of Engineering Thermophysics of the National Academy of Science of Ukraine, and me, Evgeny Sukhenko, National University of Life and Environmental Services of Ukraine. So our presentation named Methods and Future Perspectives of Animal Fat Conversion into Biofuel. Introduction. This work describes one of promising and innovative concepts for the use of biofuel from animal fats. Diesel biofuel made from cheap raw materials can compete with traditional fuels of petroleum origin, especially in terms of non-toxicity and environmental cleanliness. Raw materials for the production of methyl and ethyl esters of fatty acids can be vegetable oils, animal and bird fat, lard, yellow fat, and byproducts of fish farming. The main component of oil fats are triglycerides, which make up about 98% of the total mass of raw materials. In real production conditions, periodic emissions of fatty waste are not excluded, which leads to the loss of fat-retaining raw materials, which worsen the environmental situation. Therefore, the task of the poultry processing industry is to obtain food products from high-quality raw materials as well as third-party products in order to reduce production waste. The purpose of the work is to analyze the process of processing fat-containing waste of poultry processing enterprises into biofuel and to study its potential in providing sustainable and ecological clean energy. In the research was used technical chicken fat, CHF, which was heated to 75-80 degrees Celsius and kept at this temperature for 1 hour with constant stirring to remove moisture and then filtered to separate insoluble impurities. So, materials and methods. In the studies, technical chicken fat was used and heated to 80 degrees Celsius and kept at this temperature for 1 hour with constant stirring. Also, to melt the fat, the mixture containing the fat was crushed and water was added to it in a substrate-water ratio of 2:1. Also, separation of the fat from the water protein part was carried out by centrifugation at a rotation frequency of the centrifugator of 3,000–3,500 RPM for 20 minutes. In picture 1, you can see the dependence of fat yield on the temperature of heating. The nature of the curve shows that as the temperature rises from 25 to 80 degrees Celsius, the output of fat increases by 28%. When the temperature rises to 100 degrees Celsius, it decreases. The reason for this is apparently the formation of lipid protein complexes with an excessive increase in temperature. Thus, the optimal level of heating temperature is the interval of 78–82 degrees Celsius. At the specified temperature, the processes of heat generation of proteins are intensified, the structure of cells is destroyed, which ensures an increase in the yield of fat up to 83%. Esterification, methanol was used for preliminary treatment and sulfuric, hydrochloric, and nitric acids were tested at catalysts. Esterification was carried out at different alcohol-fat molar ratios, concentrations of acid catalysts, and duration of the reaction. Experiments were performed with heating of the reaction mixture to 60 degrees Celsius on a laboratory setup, which you can see at picture 2. When analyzing the results of research, in works it is proposed to reduce the high level of free acids in raw materials by conducting 2 or 3 consecutive stages of esterification. This is recommended because an increase in the amount of free fatty acids reduces the yield of esters due to the solubility of fats and esters in methanol. Therefore, an attempt was made to obtain the appropriate level of free fatty acids already at the first stage in order to ensure a high yield of ether and reduce the duration of biodiesel synthesis. Next page, results, the influence of time reagents on the reduction of the level of free fatty acids. The studies were conducted at a temperature of 60 degrees Celsius, using 3 durations of the reaction 60, 70, and 80 minutes. Free fatty acid levels were respectively 0.93%, 0.80%, and 0.67% after reaction for 60, 70, and 80 minutes with 20% sulfuric acid, and the methanol fat molar ratio of 40:1. Thus, the level of free fatty acids was less than 1% in all experiments. Esterification with 20% sulfuric acid catalyst at a methanol fat molar ratio of 40:1 for 80 minutes at a temperature of 60 degrees Celsius allows for a stable reduction of the amount of free fatty acids to a level of less than 1%, which guarantees a high yield of diesel biofuel after the transesterification process. Characteristics of fuel after esterification. The level of free fatty acids in the fat was 0.67%, which is a sufficient condition for transesterification of fat with methanol in the presence of alkaline catalysts. The influence of the type of catalyst, the temperature of the reagents, and the duration of the reaction on the properties of diesel biofuel was investigated. The results of the research are presented in Table 1. Biofuel yield increased with increasing reaction temperature from 25 degrees Celsius to 60 degrees Celsius, but didn't change significantly with increasing reaction duration. The minimum yield of diesel biofuel was 71.3% for 4 hours of reaction at 25 degrees Celsius with the sodium hydroxide catalyst, and the maximum was 88.5% for 60 minutes of reaction at 60 degrees Celsius with the potassium hydroxide catalyst. As a rule, next. Taking into account the obtained data, decrease in the viscosity of biofuel is observed with an increase in the reaction temperature. We can state that the density, flash point, methanol content, solidification temperature, heat of combustion, acid number, and corrosion on the copper plate of diesel biofuel don't significantly depend on the parameters of the transesterification reaction. The flash point in a closed crucible is stable and is in the range of 170-173 degrees Celsius. The acid number of the fat after esterification was 0.67 milligram potassium hydroxide per gram, and after transesterification, the acid number of the fuel decreased to 0.22, 0.3 milligram potassium hydroxide per gram. The heat of combustion of the fuel is close to 40 megajoules per kilogram and is somewhat lower than that of petroleum diesel fuel, which is inherent in diesel biofuel. The degree of corrosion of the copper plate is constantly low, indicating a low level of aggressiveness of the fuel in relation to diesel engine parts. Also, conclusions and recommendations. Sulfuric acid is one of the most effective catalysts of reducing in the level of free fatty acids during the esterification of chicken fat. The decrease in the level of free fatty acids during the esterification of chicken fat depends significantly on the molar ratio of methanol fat, the amount and type of acid catalyst, as well as the duration of the reaction. The initial level of free fatty acids in chicken fat from 50 to 27% can be reduced to 1% by using 20% sulfuric acid by weight of fat methanol in a molar ratio to fat of 40:1 in a reaction at temperature of 60 degrees Celsius for 80 minutes. Thank you for your attention. Your questions.
Yes, thank you for presentation. Are there some questions? You can raise your hand to highlight that you have such questions. Okay, Evgeny, then I have a short one. Can you analyze the potential of Ukraine in producing of biofuels in general? Yeah.
Yeah. In this time, when we are in war, the potential is pretty low. But after the war ends, the potential will be great.
Okay, do you think our European integration will be useful to improving our biofuel potential, right?
Of course,
Yeah,
it will
okay.
help us. We will take all the experience which have our European partners and improve it and provide it in our country.
Okay, thank you then. There are no additional questions, but there should be a short discussion and then maybe throw some additional questions after the main conference. Okay, so we go on to next presentation. Vlas Berezovsky and Vyacheslav Harchenko from National University of Food Technologies, Implementation of Sustainable Development Goals 6 in Ukraine, Challenges and Obstacles as example of River Ros. You're welcome.
Hello. Hello, colleagues. Do you hear me?
Yeah, we hear you well.
Okay, do you see my presentation? Okay, so hello, dear colleagues. Thank you for invitation for this conference. I have a short and simple but interesting presentation. It's about implementation of Sustainable Development Goal number 6 in Ukraine, challenges and obstacles, as example of River Ros. Introduction. So the goal 6 of the Sustainable Development is clean water and sanitation. Ensure availability of sustainable management of water and sanitation for all. This presentation considers challenges and obstacles on the way to achieving sustainable use of water resources of Ros River. Ros is a river that mainly flows in the Dnieper highlands within the Vinnytsia, Kyiv, Cherkasy regions of Ukraine. The river basin also partially covers the Zhytomyr region. The main ecological problems of Ros River are excessive flow regulation, sewage pollution, and plowing of the banks. Materials and methods. So the open data on enterprises that cause the greatest damage to the ecological state of the water resources of the Ros River, hydropower plants and sewage treatment plants, their forms of ownership, as well as precedents regarding the violation of Ukrainian environmental legislation and the response of state authorities to this were analyzed. Our results. The enterprises that cause the greatest damage to the water resources of the Ros River are privately owned. For example, the Stebliv hydropower plant is the most harmful hydropower plant for this river. It shuts the river's flow almost to zero, causing maximal eutrophication. The river flow was shut down in 2015 by the owner of the power plant after its privatization. You can see on the picture the photo of this power plant when it was in state property. There is a dam and there is a constant ecological water flow. After privatization, this flow was shut down. And none of the penalties or the courts made the owner to return the river's flow to the normal value. Second, the Белоцеркив Вода is a private company that holds the sewage treatment facilities of the Белоцерква city in a concession and is the biggest polluter of the Ros River. Starting from 2013, the company saves the money on the waste treatment by simply discharging all the waste, used activated sludge, directly into the river every year. And the maximal fee the company ever paid per year was only 50,000 hryvnias. As on the pictures, it's represented actually the sewage discharge of this enterprise that goes to the Ros River and the photos of river in that place over different years. So they just discharge the wasted active sludge to the river. Sorry for the disgusting picture, but that's an Actually, that's our topic. Excuse me. Yeah. So we see that in Ukrainian legislations, there are no effective mechanisms of influence on private business by the state regarding environmental protection. On the contrary, there are a number of legislative incentives for the maximal use, depletion of these resources. The interests of private business are better protected by law than the natural environment is. It should be noted that such predominance of business sectors based on the use of natural resources over the technological or intellectual sectors is typical for the relatively poor countries, so-called third world countries or developing countries. And in conclusion, I can say that sustainable development ensures careful use of natural resources, particularly the balance between use and saving. In turn, the business, especially a private one, means the maximal use of these resources up to their depletion. One of the ways to preserve Ukrainians' water resources and to achieve the goal number 6 is the reorientation of business from the raw material industries to those that consume less use of natural resources, technological industries, IT, so on. Thank you for attention. Maybe questions.
Yes, thank you, Vlas. So then I have the short one. Why do you focus on the Ros River? And are there some rivers that are more affected by human?
Okay, thank you. Very good question. The Ros River is a quite good example for us because the significant effect of the ecological state of this river happens actually in those years, starting from end of 90s, beginning of to year of 2000. So that means that we still remember the better state of this river. So the spoiling of this river happens actually those years right now. That's why this example is quite good. And the second reason is that I simply love this river, like spending, and so enjoy spending time there. So that's more personal. And regarding question, are there most polluted rivers? There are more polluted rivers, like Dnieper one, like river Teteriv, but the river Ros is the most regulated river in Ukraine, regulated with artificial barriers, dams, and hydropower plants. So from this point of view, from artificial barriers, this river is number one.
Have you analyzed and compare the results of your investigation with government standards related to water quality, to is it suitable to drinking or to have some recreation?
You mean results of the analysis of the quality of the water?
Yeah.
So so there are official results of the water investigations. Actually, the water from this river is usually kind of third or fourth class. So like intermediate or bad, yeah. so we have 5 classes of water quality in Ukraine, and usually the water on Ros River corresponds to third and fourth class. And that's one point. And the second point, of course, is how truthful are the analysis represented by our government.
Okay.
One more question.
Yes.
Yeah. Lars, thanks for your contribution and for your position. Yeah, I know you are in the topic. That is why my question: how optimistic you are about changing the situation? I mean, I totally agree with you that we have a really poor legislation, yeah, especially in terms of legal responsibility. What is your really assessment for the nearest or for the far future in this field in Ukraine?
Thank you for your question. Unfortunately, I'm very pessimistic because we see that the protective of the nature, it's something that only rich and quite developed countries can afford. And now we see the trend that we're going to not directly to this direction. And that will be the topic maybe for my future presentation. That's more philosophical question is if the sustainable development can be achieved on all the earth and not only on a particular countries. Because we understand that until all the dirty enterprises are localized in Ukraine, in other countries, some other countries still can keep their nature virgin and unspoiled.
But we maybe should not transfer, but eliminate this, let's say, dirty productions.
It should be, but it never happens. The real, let's say, not optimistic trend is that all not so rich countries, relatively poor countries, earn money by destroying their nature, by depletion of the resources.
Okay.
Unfortunately, it's our reality.
Yeah, unfortunately. Okay, I got your position. Yeah, thank you, Lars.
Yeah, yes, thank you.
Yes, thank you. Okay, there are no additional questions. And thank you again, Vas. We go to the next presenter, Serhiy Kovalenko, with presentation of efficient housing using industrial hemp. It's Hempire LCC, Kyiv, Ukraine. You're welcome.
I guess we don't have just now in the Zoom the yeah. Let's go next.
Okay. Okay, the next presentation is Olena Boyka, Irina Polyakova from Zaporizhia National University, with presentation of European Green Deal as a roadmap for the restoration of Zaporizhia. Olga, Irina, are you here? Okay, then the next presentation is Marina Yeremova and Lyudmila Tarasovich from Polisia National University, Zhytomyr, and this presentation to circular bioeconomy for sustainable development in Ukraine.
Good day, dear colleagues, dear friends. Thank you for invitation. And today I would like to share a few minutes with you to talk about circular bioeconomy for sustainable development in Ukraine and in the world. So let's talk under current conditions. Economic activity of human mostly aimed at satisfying their own needs without proper awareness consequences for environment. And this leads to emergence of global problems, which create some imbalance in ecological and economic systems and endanger our life and our health. And under indicated conditions, latest achievement in biotechnology, attractive for economy, for environmental protection. And we talk about bioeconomy. Bioeconomy, the area of economic activity, which allows us to transform biomass into a newly created product with the help of various biotechnological process. And we use this technology in Ukraine. And let's talk about advantages of bioeconomy for Ukraine. First of all, it's raising level of employment and intellectual activity, overcoming the country's energy dependence. It's a vital need for our country, reducing dependence on non-renewable natures, manufacturing safe industrial products, high level of food safety, and improvement of quality and life expectancy of our population. And in the world, bio industry occupy the third place among leader sectors. And bioeconomic direction is actively developing in vast majority developed countries. Widespread and diverse. For example, Germany, Italy, Spain, France, Sweden, etc. The main idea of circular bioeconomy combined our concept is that consumption, all goods are returned to production cycle or cycling. So as we talk the concept of circular bioeconomy lets organic waste become raw materials for next production. Circular bioeconomy, it's combined two cycle, technocycle, biocycle. Biocycle about organic waste, biotechnology, bioenergy, and technocycle, it's more about material flows and innovative decision of consumption, sustainable consumption, eco-design. So circular bioeconomy, it's a way to sustainable development. It's a recycling and to overcome gap of decoupling. And let me talk more about Ukraine and bio-based economy and activity in our country, because these concepts develop depending on the availability of natural resources. So let me introduce our region, the Zhytomyr region, and its natural raw materials potential for bio-based economy. The region occupies one of the leading places in harvesting of forest resources, and particularly in terms of wood reserves. Registered economic entities determines greatest biomass potential of forestry and wood industry waste, almost 8%, and vast majority producers solid food from wood industry waste. Production volume is 135 tons per year, mainly full pellets. Approximate number of manufacture in our region, it's 29. In addition, there are two producers of heat from biomass in Zhytomyr region, Only one power plant, Poliska power plant of which city, operates on wood residues from the wood industry and energy below. And 2 power plants produce biogas. As for the agriculture, natural resources from the agriculture, in general, biomass from organic agricultural waste is promising for the Zhytomyr region, taking into account the great number of economic entities employed in agriculture, especially in animal husbandry, and up to 125,000 hits as opportunity to obtain bioenergy from manure. The Zhytomyr Oblast, the region has significant share of crops residues, which used to meet society's energy needs. For example, total potential of plant biomass waste is almost 597,000 tons oil equivalents. Particular energy crops 43%, corn for grain 29%, wheat 12%, etc. And I would like to focus your attention on cultivating of energy crops as important component of development of bioenergy. And the Zhytomyr region, areas allocated for cultivation of energy crop amount 147 hectares, of which more than 100 hectares allocated for miscanthus and 47 hectares it's a poplar. For example, Energetica 67 hectares, and Policia National University is planting 35 hectares miscanthus as a part of implementation of grant project of our university. And Bio project uses land for growing energy trees. It's a poplar, willows, 45 hectares. And there are more than 78 hectares of unused land in the Zhytomyr region, which can be considered as a potential for growing energy crops in the future. In addition to above mentioned enterprises of the Zhytomyr region that process forest and agricultural waste, it's the main of them: EcoGrant, Zhytomyrtorf, Dionys Biogas Energy, Pellet Energy, etc. Peculiarity of these enterprises, these enterprises taking into account natural raw materials of our region, potential. Our region is transforming of biomass into particular residues forestry production, sawdust, wood shavings, livestock waste, bird manure, cattle manure, plant waste, sunflower husks, wheat waste, straw, peat, etc. Transformation into full briquettes, full pellets, peat, fuel brackets, biofertilizers, as well as biogas for production of electrical energy. And according to the result of survey of our companies of our region, about challenges to develop bio-based economy in our region, and the answer was its challenges was lack improved long-term goals, underdeveloped regional biofuel market, inefficient state support for producers of biomass and biofuels, importance of regulation, the waste sorting system in our region, but lack of this system, lack of regional logistics center, and undefined enterprises position in energy use of agricultural reduces. And we know that this way is very important for us, and we must do all to overcome all these challenges in order to develop circular bioeconomy as a way to achieve goals of sustainable development. That's all. Thank you for attention. Maybe questions.
Yes, thank you for presentations. So, any questions?
May I?
Yeah, sure.
Marina, thank you. You mentioned the survey of your businesses. I understand regional businesses, yeah, companies. Can you say, do you have some positive examples, some cases of companies who really, I don't know, implement this bioeconomy, circular economy approach?
I talked about enterprises that produce biofuel, and I would like focus your attention at the waste processing plant that started working in Zhytomyr this year. It's a good practice for our country and for our region too. And we suppose it will be nice opportunity to maybe increase our waste system in our region.
So it works right now, yeah?
Yes.
Okay.
Excuse me?
I mean, this waste treatment plant works right now?
Yes,
Yep.
right now it's working.
And how is it powerful? How much waste they may treat?
Not so much as we would like. Now almost 5-6 tons may use for week.
For week?
Week.
Not so much, yeah? Not so much. Okay. Okay, but yeah, thank you.
Okay, we also see that there are no additional questions. Then thank you so much for presentation. And we go to the next presenter. It's Serhiy Telima and Alexander Dyatel from Institute of Hydromechanics of National Academy of Science of Ukraine and State Ecological Academy of Postgraduate Education and Management, Kyiv. With presentation some varieties biofilm forming at wastewater treatment in bioreactors. So you are welcome. We see your presentation, but we don't hear you.
Окей, доброго дня. Я перепрошую, шановні колеги, в нас сталася непередбачувана ситуація. Доповідач пан Сергій захворів. Я, на жаль, англійською не володію, тому прошу дозволу українською, якщо можна.
Так, звісно, одна з опцій це була як виключення, що ви можете зробити презентацію англійською мовою, а презентувати українською.
Англійською, на жаль, так сталося життя. Тому перепрошую. Отже, доброго дня, шановні колеги. Вашій увазі пропонується доповідь на тему деякі особливості формування біоплівки при очищенні стічних вод в біореакторах. Отже, доповідач Дятел Олександр, Державна екологічна академія дипломної освіти та управління міста Київ. І співавтор, головний автор Сергій Телима, Інститут гідромеханіки Національної академії наук України. Отже, відомо, що в останні роки в Україні різко погіршився екологічний стан водного середовища. Інтенсивне навантаження на нього пов'язане з неконтрольованим забрудненням різного походження річкової мережі, водойм і водоносних горизонтів, суттєво знизило якість питної води. А в окремих регіонах держави виник дефіцит водних ресурсів, придатних для водопостачання населення. З іншого боку, війна з Росією створила додаткове техногенне навантаження на всю екосистему нашої держави в цілому. Тому виникає необхідність у будівництві та впровадженні сучасних технологій очищення стічних вод на об'єктах різного профілю, що сприятиме покращенню екології в Україні у післявоєнний час. Одним із способів покращення ситуації зі стічними водами, які забруднюють водне середовище, є їх додаткове очищення. Зараз найбільш ефективними методами очищення забруднення є методи біологічного очищення з використанням біореакторів різних конструкцій. Актуальність проблеми очищення стічних вод в нашій державі на сьогодні безсумнівна. Багато наукових праць і практичних рекомендацій присвячено різним аспектам вирішення розглянутих завдань, наприклад, фундаментальні роботи зарубіжних вчених, таких як Бейналя і Генца. А серед вітчизняних робіт слід відмітити роботи доктора Олійника та його колег. Це Інститут гідромеханіки Національної академії наук України, Капояна, Айда-Петяна, а також Сергія Васильовича Толима. В процесі проведених досліджень проведено аналіз впливу деяких динамічних процесів та біохімічних перетворень на характеристику та структурні особливості біоплівки при очищенні стічних вод у біореакторах різних конструкцій. Розглянуто різні типи біоплівки та основні її параметри, які характеризують її структуру та можливість експлуатації з метою обґрунтування та розробки основних підходів до створення математичних моделей процесу формування біоплівки, зокрема її товщини з постійною та змінною пористістю, при різних режимах роботи біореакторів для більш ефективного очищення стічних вод від забруднень різного походження. У реальних умовах розглядається, як правило, очищення стічних вод у біореакторах із завислим біоцинозом і неоднорідною плівкою. За таких умов для такої біоплівки використовується добре відоме рівняння, що описує утилізацію органічних забруднювачів з одним обмежувальним субстратом в стаціонарних умовах. Дане балансове рівняння описує швидкість видалення субстрату в умовах нелінійної кінетики реакції Моно. У запровадженні математичній моделі неоднорідної плівки прийнятий зв'язок між ефективним коефіцієнтом дифузії та щільністю біоплівки, отриманий в результаті експериментальних робіт. Аналіз проведених робіт показав, що процеси вилучення субстрату залежать від концентрації мікроорганізмів у біоплівці. Однак при значних його концентраціях відбуваються деякі зменшення субстрату, що пов'язано із зменшенням коефіцієнту дифузії, так як видалення субстрату контролюється у більшій мірі процесами масообміну. Ось на екрані наведено рівняння балансу відносно швидкості проникнення субстрату в умовах нелінійної кінетики реакції Моно. Позначення до цього рівняння є в роботах Бейнали, а також пана Олійника. В цілому процеси вилучення субстрату залежать від концентрації мікроорганізмів у біоплівці. Однак при значних концентраціях F від X відбувається деякі зменшення субстрату в одному. Це можна пояснити тим, що має місце значне зниження коефіцієнта дифузії, а процеси екстракції субстрату більшою мірою контролюються процесами масообміну та мають більший вплив порівняно з концентрацією від F від X. В рівнянні тому, що ви бачили на попередньому слайді, було прийнято ряд умов, зокрема і те, що субстрат транспортується шляхом дифузії та використовується мікроорганізмами відповідно до відомого кінетичного рівняння Моно. Ефективну дифузію та щільність біоплівки можна розрахувати на межі кожного шару сертифікованої біоплівки. Процес у біоплівці можна розглядати в стаціонарних умовах. Субстрат переноситься в перпендикулярному напрямку, а біоплівка формується на непроникній і неактивній поверхні. Ми також припускаємо, що забруднення транспортується до нижньої поверхні в напрямку лише шляхом дифузії. Розв'язки рівнянь того, що ви бачили на екрані, відповідно до наведених залежностей X від FC, враховуються значні концентрації, де ZF та концентрація ефективної дифузії, запропонований в роботах Бейналі. При формуванні однорідної біоплівки прийнято наступне. По-перше, ця однорідна біоплівка має ефективний коефіцієнт дифузії, що дорівнює середньому значенню ефективного коефіцієнта дифузії для однорідної
стратифікованої біоплівки. По-друге, однорідна біоплівка має значення ефективного коефіцієнта дифузії, що дорівнює значенню для зниження поверхні стратифікованої біоплівки. І ці коефіцієнти вважаються однаковими для верхньої поверхні. Слід зауважити, що в цілому рішення проблеми, пов'язаних з біологічними очищеннями стічних вод від різних забруднювачів за допомогою біоплівки, залежить від прийнятої моделі структури біоплівки. На основі аналізу існуючих літературних джерел, а також отриманих результатів досліджень, зроблено наступний загальний висновок, що при розробці та використанні моделей біоплівок достатньо обмежитися розглядом і дослідженням одновременних моделей з плоскими поверхнями. При цьому для врахування кривизни поверхні можна використовувати поправочний параметр, значення якого для різних геометричних форм отримано експериментальним шляхом. При використанні біоплівок з плоскими поверхнями необхідно звернути увагу на те, що в моделях біоплівки бере участь не вся товщина біоплівки, а лише її активна частина. Активна частина біоплівки в умовах вилучення з різних субстрактів, наприклад, з органічних забруднювачів і азоту, складається з різних бактерій, і тому процеси, які відбуваються в біоплівці, зокрема її зростання, будуть залежати від конкуренції між цими бактеріями, оскільки обидва типи бактерій використовують кисень для свого живлення. Крім того, встановлено, що на початку очищення стічних вод відбувається значне зростання біоплівки, яка потім інтенсивно зменшується, що також призводить до значних змін у розподілі біомаси. Формування товщини біоплівки з плином часу при великому і низькому співвідношенні органічних сполук і азоту відбувається приблизно протягом 10 днів. При великому співвідношенні органічних сполук до азоту зростання біоплівки відбувається в основному за рахунок видалення органічної речовини гетеротрофами, а видалення азоту автотрофами вже відсутнє. При низьких співвідношеннях органічних сполук до азоту відбувається значна нітрофікація разом із зростанням біоплівки, а видалення азоту починається майже після повного видалення органічних сполук. При зміні внутрішньої щільності змінюється і формування активної біоплівки. Зростання біоплівки істотно залежить від розпаду біомаси, тобто від розташування в ній окремих компонентів. Встановлено, що на формування активної частини біоплівки впливають процеси утворення інертного осаду та позаклітинних полімерних речовин у складі біоплівки, які займають значний додатковий об'єм під час росту біоплівки та в цілому впливають на параметри біоплівки. На основі аналізу результатів теоретичних та експериментальних досліджень розроблено сертифіковану одновимірну модель структури біоплівки з домінуванням розміщення гетеротрофних бактерій на поверхні біоплівки та зростанням ідентифікаторів по глибині біоплівки. Для оцінки впливу стратифікації біоплівки також було проведено і досліджено моделювання біоплівки з однорідним розподілом біомаси по товщині біоплівки. У випадку однорідної біоплівки відносна кількість гетеротрофів, автотрофів та інертної маси змінюється з часом в результаті загального росту. Таким чином, однорідний розподіл біомаси зменшує переваги гетеротрофів, які більше не домінують на поверхні власної біоплівки. В результаті проведених теоретичних та експериментальних досліджень встановлено, що під час очищення стічних вод від розчинених забруднюючих речовин різного походження верхня поверхня біоплівки утворюється переважно криволінійно та різноманітно пилоподібної форми. В результаті проведеного аналізу з використанням експериментальних даних було з'ясовано, що для біоплівки, яка має щільну тверду матрицю та плоску поверхня оцінка відповідає значенню параметру АЕ рівне одиниці. При значеннях більше 10 ми маємо складну структуру поверхні біоплівки типу гріб, різні скупчення і канали. В цьому випадку цю складну структуру біоплівки слід враховувати при проведенні розрахунку. Таким чином, параметр АЕ можна розглядати як міру неоднорідності біоплівки. Чим більше нерегулярна і геометрично неоднорідна структура, тим більше значення АЕ відхиляється від значення, отриманого для плоскої біоплівки. Як пам'ятаємо, рівне воно одиниці. Чим більше піків у біоплівки, тим більше нерегулярна її структура. На нашу думку, дане складне питання слід досліджувати і надалі. У дослідженнях, проведених під час екстракції забруднюючих речовин біоплівками, сформовано в різних біореакторах, профілі концентрації в біоплівках розраховувалися за умови, що концентрація забруднюючих речовин на поверхні біоплівки вважалася рівною концентрації забруднюючих речовин на поверхні біоплівки. При цьому гідродинаміка потоку і концентрація Лє в різних біореакторах була різною, і цей факт не враховувався. Однак навіть при повному перемішуванні в біореакторах спостерігається утворення органічного шару або так званої рідкої біоплівки. Тому процес масопереносу забруднюючих речовин в біоплівку необхідно враховувати в моделях біоплівки. У деяких роботах розглядається утворення органічного шару та необхідність його врахування на величину потоку забруднюючих речовин, що надходять до біоплівки через їх поверхню. Отже, в результаті проведених експериментальних робіт було визначено, що для ефективної роботи біореактора товщина органічного шару повинна бути в межах 100-200 мікрон, а при значенні його товщі порядку 500 мікрон потік забруднення буде зменшуватися майже на 70%. Отже, товщина структури поверхні біоплівки також залежить від завантаження і гідродинамічних умов. Біоплівка з однорідною гладкою поверхнею має місце при високому тангенціальному стуві та низькому навантаженні. Такої біоплівки більша кількість, її товщина зменшується із збільшенням жорсткості поверхні біоплівки. Окрім того, в пограничному шарі спостерігається не тільки дифузія, а й конвективний транспорт субстрату, а масообмін через нього більший, ніж через поверхню без біоплівки. Проведені дослідження дозволяють зробити наступні висновки. Для практичних розрахунків очищення стічних вод пропонується одновимірна модель однорідної біоплівки з урахуванням отриманих оцінок та обмеження на її використання. Порівняння результатів розрахунків з експериментальними даними показало, що така однорідна модель в багатьох випадках добре узгоджується з експериментальними і запропоновані деякі рекомендації відносно визначення форми поверхні біоплівки. Загалом аналіз теоретичних досліджень показав, що екстракція субстрату в основному відбувається в початковій частині біоплівки, яка становить приблизно 20-25% від загальної товщини біоплівки. Слід зауважити, що запропоновані однорідні моделі біоплівки з постійною товщиною потребують подальшого вивчення та удосконалення для більш достовірної оцінки процесів формування структури біоплівки, зокрема для урахування неоднорідності її товщини, впливу різноманітних гідродинамічних факторів функціонування біоплівки, наявність в ній інших неактивних речовин, зокрема інертної біомаси та полімерних речовин тощо. До речі, є домовленість з Бортницькою станцією очистки стічних вод щодо встановлення такого експериментального біореактора на їх потужностях і для проведення, скажімо так, подальших натурних досліджень. Дякую за увагу.
Так, дякуємо за увагу. Colleagues, do you have any questions? Чи є запитання? Скажіть, будь ласка, щодо станції аерації Бортницької. Чи вони взагалі планують після того масштабуватись, чи вони хочуть залишитись лише на якійсь пілотній установці?
Вони взагалі планують, якщо все пройде вдало, то вони планують розширитися, тому що, як відомо, метод очистки в біореакторах в світі досить широко використовується в таких містах, наприклад, як Осло, Рим. Тобто вони до такої, скажімо так, очищують стічні води до такої якості, що її можна подавати як потрібно. І все це за допомогою також, в тому числі, використання власне біоплівок.
Зрозуміло. Дуже дякуємо за презентацію. Питань
Можна ще одненьке питання. Трішки так про Бортницьку станцію. Чи не знаєте, чи не підкажете, де саме знаходиться вже випуск у річку Дніпро? Наскільки мені відомо, там іде магістральний канал біля 8 кілометрів з розсіяним випуском, а далі вже він впадає в Дніпро. Чи не підкажете, як його знайти, як його подивитись?
Розумієте, вони скидають не в одній точці, а як ви правильно зауважили, в декількох. Росіяни скид. Не знаю, там найнижча точка, певно, кілометрів 9 від нижче по течії від Бортницької станції. Але розумієте, проблема в тому, що в Бортницькій станції очищення стічних вод використовуються, ну, скажімо так, умовно, застарілі технології. Тому от, якщо ви слідкуєте за цим всім, там японці пропонують модернізувати її, ну і, звичайно ж, наші науковці теж весь час працюють над тим, щоб все-таки води були більш очищені, більш кращої якості. Тому що ви ж розумієте, що інші міста, особливо південного регіону, які йдуть нижче по течії Дніпра, вони використовують цю воду, власне, для господарсько-питних потреб. А очистка наша, на жаль, вимагає реального перегляду отих всіх процесів, що зараз там відбуваються.
Ну, так. Добре, дякую.
Дякую.
Дякуємо. Ну, тоді будемо переходити до наступної презентації. Ще раз дуже дякуємо вам, Олександр, за таку презентацію.
Дуже дякую за увагу. Гарного дня.
Гарного дня. So the next presentation is Olena Chukurna from State University of Intelligent Technologies and Communication, Odessa. And presentation is methodology of digital project management in the context of sustainable development strategy.
Good afternoon. We can see the presentation. Can we see presentation?
Yeah, we see presentation and hear you well.
Thank you. Good afternoon. First of all, I want to thank the organizers of the conference for the opportunity to speak and present scientific achievements. We represent the State University of Intelligent Technologies and Telecommunication from Odessa, Ukraine. And our subjects of our report, methodology of digital IT projects management in the context of sustainable development strategy. And the methodology of project management in the condition of the development of the digital economy should be formed and implemented in the context of achieving the goals of the sustainable development strategy. And the choosing the most effective project management methodology is crucial for the successful completion of a digital IT project. They selected methodology determines how communication, management, and control will be organized within the digital IT projects and IT team. And on next slide, we presents the classic, well-known classification of IT projects, traditional waterfall model, agile model such as Scrum, Kanban, and process-oriented model, Lean and DevOps. And the next slide, we can see waterfall methodology. We can see the essence of the waterfall cascade model and structure of the waterfall methodology. Waterfall is a common methodology for most IT projects used by outsourcing service IT companies. Waterfall the model cascading product development. It likes the flow of water, direct teams to solve tasks consistently and strictly according to the origin plan. Next, most famous methodology is Agile. We can see the essence of the Agile model and structure of the Agile model. Agile methodology is a set of methods for software development that makes work on a project sequential, flexible, and adaptive to changes. The Agile methodology is based on open communication, collaboration, adaptation, and trust between team members. And visual comparison or a comparative analysis from Agile and Waterfall. And the next slide present advantages and disadvantages of waterfall and agile methodology. Advantages waterfall are it's easy to manage the process sent to the rightly of the model and clear fast sequence. The process and results are documented in detail for future transfer of experience. Each stage has specific deliverable and defined verification process, and etc. We can see. And the main advantages agile methodology for IT projects, effective in condition of a limited budget, satisfied the changing need of the user, fast iteration result and implementation risk are identified and eliminated during iteration. Each iteration is an easily manageable part of the development of IT product, allows you to go back to previous stages, make changes, and improve the IT products in each stage. And the next, we can see a flexible agile methodology such as Scrum, structure of the Scrum methodology presented on the slide, and principles of the Scrum management system. Scrum is an iterative adaptive framework for small teams up to 12 people to manage their work through a set of value principles and practice. Its most popular methodology, Agile, and used IT company Kanban. The next methodology, Agile, flexible, and Kanban is an iterative framework that focuses on visualizing the entire project on boards to increase process transparency and collaboration between team member. And Kanban can be used in any knowledge work environment. It is particularly effective in situations where work arrives unexpectedly or when you want to release as soon as ready without waiting for the completion of their work tasks. And the Kanban board consists of 3 indicators, which we see, doing, review, and DAO. And the slide 10, 11, and 12 visually present a comparative analysis of methodology Agile, Scrum, and Kanban. For example, track structure, Kanban is cart and board, Scrum is sprint and sprint backlogs and product backlogs. Next criteria, progress tracking, Kanban is visualization of individual task and progress, Scrum is checkpoints for flexible adaptation, prioritization, Kanban with height too low, and Scrum is acquired within sprints. Best team fit, Kanban is very distributed teams or teams with many players. Scrum is on 12 people in teams. And the next slide presented comparative analysis, Scrum and Kanban, and visual. We can see Kanban and Scrum and the Agile, Scrum, Waterfall, so we can see visual the same. And the next methodology is used IT company. It's a process-oriented model such as Lean and methodology DevOps. Process-oriented Lean is both a methodology and a philosophical principle. Its main idea to maximize value for the consumer while minimizing cost. Lean aims to achieve the idealistic principles of zero waste. This entails minimizing resources that are spent inefficiently on unnecessarily overly wasteful or unpatable and unpromising direction. And DevOps is a set of methodology, tool, and culture philosophy that enables the automation and integration of software development and IT operation process. And the end, we can see comparison of the most common methodology for managing digital IT projects based on specific criteria. And the main criteria is compliance with sustainable development strategy. We can see that methodology Lean and methodology DevOps is the most relevant methodology, can be used digital IT projects in digital economy. The Lean methodology is highly adapted for use in the context of implementing sustainable development strategy by ensuring frugal production. Business models implemented on the principles of Lean philosophy are realized through the principles of resource efficiency by eliminating waste in all value streams rather than the individual points. Business process require less human effort, less space, less capital, and less time for production with significantly lower cost and fewer defects compared more accurate. And conclusion we can see on slide, and I can think and I can say that Lean and DevOps is the most useful methodology for the successful completion of a digital IT projects and methodology of sustainable development strategy. And thank you very much. Thank you for attention and the opportunity to participate in the conference.
Yes, thank you so much. Are there any questions? Okay, then I have. Can you highlight again the criterion which were used to analyze correspondence to sustainable development?
Quotable is very much quotable. The main goals of a sustainable development strategy, the first, and the second used IT methodology depend on team, many people work in this team, what kind of product team can be used and can be work, and political factors, economical factors, environment, social, external, internal factors, many factors when we decided to use the methodology Lean or DevOps or Agile or Waterfall. It depends on many factors by the convenient on sustainable development strategy and project management standard GPM P5. That's my opinion.
Okay, and also, what do you think the results of your study, they can be used only in AT field, or it also can be used, for example, in environmental safety fields? For example, when you implement some new technologies, there's also stages like it's in Scrum and Kanban, like someone propose the idea, someone implements it, someone should review it, and then the task is done. So what do you think? Are results of your study is implementable in other fields of human activities?
There are this methodology, Scrum, Kanban, Agile has a lot of advantages and disadvantages. It depends on IT projects, depends on IT teams, depends on goals, and the by criteria we can see the standard. We choose Lean methodology is highly adapted for use in the context of implementing sustainable development strategy by ensuring frugal production is the business model in the philosophy Lean, and this is the The summit learn transformation is relevant digital economy, digital IT projects.
Okay, thank you. I see that there are no additional questions, then thank you so much. And we go to the next presentation. Inna Popova and the colleagues, there is a pretty huge list of authors from National University of Life and Environmental Sciences of Ukraine and National University of Food Technologies Kyiv, non-destructible analysis of the content of mineral components of chicory and to increase its environmental safety. You're welcome. Colleagues Inna Popova, Igor Polomarchuk, Maria Zhaplinska, Mikhailo Mishtruk, Volodymyr Vasilyev. Okay, then we go to the next presentation. It's Oksana Chemistrenko, Bila Tserkva National Agrarian University, parasitized contamination of honey. Oksana, are you here? Okay, then the final one, wet wipes as a case of environmental problems, a mini review. Natalia Tkachuk, Lyubov Zelena, Yaroslav Novikov, Taras Shevchenko National University, Chernigiv Collegium, and Danila Zabolotny Institute of Microbiology and Virology. Okay, absent also. So maybe this is the full list of speakers that was noted in this section. Maybe someone who was absent want to present their presentation. Okay, then general agenda is finished. And maybe someone have topics for discussion. Maybe someone want to highlight the presentation that was interesting and important for you. And maybe we can have some discussion for you have additional questions that you wasn't able to ask during main stage.
I just want, Zhenya, thank you. I just want to give some idea. First of all, you know, in just different region over Ukraine, today we have some issues with electricity. That is why some people may be absent, unfortunately, and maybe we will return to their report later if we will have some time slot. And one more issue, we have, as you know, poster section in each our sectoral these activities. That is why just after the finishing our oral discussion, we will turn on the screen slideshow of poster presentations, and you will have opportunity to look through. It will be actually active during all the lunch time and right now after the discussion. And after the conference, you can see all the posters on the site of the conference, but right now you can see it as well on the screen, and you may again be in contact with authors and maybe discuss some issues. Okay, Zhenya, please.
Yeah, I just wanted to also highlight that today we have pretty vivid presentations in terms of that. I hope that those who are not specialists in environmental science, it was useful for you in terms that you have some environmental things and now you can implement those environmental ideas to ensure sustainable development. Also, there was a lot of things related to project management. And I think that environmentalists and scientists who do not use those project management instruments, this is important for you to just to think about using those tools. For example, agile method is very essential to plan your investigations. So this is what was pretty broad, but very related to sustainable development agenda, and hope that it was useful for you. So thank you all for participating.
Okay, thank you all. First of all our speakers for today bright reports, and thanks all of us listeners. Yeah, and yeah, we will have just now this poster activities, and we will have a lunch till 2 p.m. And please, after the lunch, we will have the section on economy as one of the main pillars of sustainable development. So please, you are all welcome to this section. Again, you know, it's important to share our ideas, knowledge, even from different fields. That is why I hope it will be interesting for all of us, not only for guys from science of economy, something like that. So if you don't mind, I'll just now will share this presentation. I mean a slideshow on our poster demonstrations. I guess you can see right now, yeah? Okay, it will be open. I only think that I will stop the record, and actually we will have these activities during all the break time.